All right, welcome everyone to the next lesson in this series. And in this video, we will look at Calico network quality of service controls for Kubernetes. Now, if you work with Kubernetes, you're probably already familiar with concepts such as CPU limits and memory limits. These are controls at your disposal to ensure that a workload in the cluster doesn't starve other workloads of compute resources. Now, Kubernetes natively doesn't have such a control for networking resources. However, Calico, as a specialized CNI, offers certain network quality of service controls. And in this lesson, we will be exploring one such control, namely bandwidth limits. Okay. Now, in a Kubernetes node, you're going to have dozens, if not hundreds, of pods. And all of these pods are sharing essentially the same network resources of that given node. And if you look at the host network interface card of such node, it's going to have a limited amount of bandwidth. It could be a 1G interface, a 10G interface, a 40 gig interface, and I've also seen 100 and 200 gig interfaces. Now, when you look at a single pod in the cluster, by default, the bandwidth available to a pod is unlimited. And if you have a noisy neighbor, that pod could easily starve other pods of networking resources in a cluster. So it's a good practice to have or enforce certain bandwidth limits to a pod so that they don't exceed that threshold and impact other workloads scheduled on that node. So in this lab, we will look at how such controls can be enforced using Calico. Let's get started. All right, I have already gone ahead and provisioned the lab in my environment here, and you can find this lab in folder 12 in the Git repo, so folder 12-calico-QoS. And once you've run the deploy script and exported the kubeconfig file, you could do a simple kubectl get nodes to make sure the cluster is up and running. In this case, we have a simple 2-node cluster to demonstrate quality of service. And next, just do a kubectl get pods. You're going to find a couple of pods. We have an iPerf client and an iPerf server deployed in this cluster. And we will be using these workloads, these pods, to demonstrate quality of service. Now, what I'm going to do next is run a test without any QoS controls. So let's go ahead and do that. And if you look at the throughput or the bit rate, we are seeing about 16 gigabits per second, 16, 17, 18. And this workload, this test currently is maxing out the throughput. There are no limits enforced. So assume this to be a noisy neighbor in the cluster. It could easily saturate the networking resources and starve other workloads of those resources. And this could manifest application issues, timeout, latency increases, etc. So next, what we're going to do is we're going to deploy a couple of additional iPerf clients and servers. And this time, we're going to specify a network limit using annotations that Calico understands. So for this workload, we're going to give it an ingress and an egress bandwidth limit of 10 megabits per second. Okay. So with those workloads now up and running, so if I do a kubectl get pods, right? So we have the iPerf client and server where we have enforced certain QoS limits. You could even apply these annotations for running workloads, right? And Calico will translate that into controls in the data plane. So with these workloads up and running, we can now do a test. And this time we see that there was an initial burst, but then the bandwidth was limited to 10 megabits per second. Okay. Now, when you look at the bitrate over here, this is the average from all of this. So initially there's going to be a burst and then the application is going to get throttled. That's how the token bucket algorithm works. However, you can see that if this application, continues to transmit, so if I say instead of 5, let's go with 10 this time, you're going to see that bandwidth smoothen out and, it's going to hold it at 10 megabits per second. Okay. All right. So there you have it. So it's pretty much, that simple to enforce QoS controls. When you look at the bandwidth, you're going to see that initial spike. And once the burst rate or once the tokens have been exhausted, it's going to smoothen out and then maintain that control for the given workload. Okay. All right. I mean, that's pretty much it. It's a relatively straightforward lab. And I hope you understand the importance of this control in production environments, especially if you have multi-tenant environments. You have to guarantee your customers certain service level objectives, and you want to make sure that a given workload, or even a rogue workload for that matter, does not consume all of the resources in the cluster, impacting other workloads. So if you have applications or workloads for logging, storage, database that do things like replication, you could even consider applying QoS controls at certain times of the day so that these workloads do not impact other running workloads during peak hours. Okay. All right. So I hope you found this useful. That's it for this lesson. Thanks for watching. I'll see you in the next one. Bye for now.